And welcome. As usual, I'm going to have a moment of nervousness while I try to figure out if the stream has in fact launched, but it says it has, so let's assume it has. Lambda Lab Week 6. So this is where I left the list of new things and fixes that I was going to work on last week, but I'm thinking about something different during the week. I thought about it before, but it's back on my mind now because of a couple of problems I looked at recently. Which is what I'm calling, for want of a better word, packing functions. The idea is thinking about sort of shapes that can fit inside shapes, and an Excel-friendly way to do that. So the most kind of recent example of this is Tim Froelic's card case from the MEWC knockouts, and the idea in that was that you had to figure out. Let's just see. I've got my suit, and I've got my cardboard. Hey, Bo. Um, so, if you had a set of 12 cards that might be, you've got these 4 cards of diamonds, and you've got, I don't know, these 3 sevens, and you've got a few other random cards here and there. Obviously, the way I'm representing it is hinting at the way I'm thinking about solving it, but the idea was to figure out what sets you have. So, for example, here you've got a set of 4, here you've got a set of 3, so it's basically either any kind of straight line of length at least 3, or no, I think it was either 3 or 4, but not 5 or something. Maybe it was just 3, or any 3 or 4 in the same row. The interesting thing about this is, like, if you just had to figure out, are there 4 in a row or are there 3 in the same row, that's relatively easy. But what you had to do here was figure out what is this one's actually about the most value, but basically the most sets you can make. So, for example, you might have to make a trade-off between, let's say, this situation. If you take that set, then you can't take that set. So it's not enough to figure out, here's one set and here's another set. And if you have a list of all the sets, it's pretty easy to figure out, there's one and there's one. But to figure out what's the lowest, the best score I can get by removing sets, if sets conflict with each other, that's a much more tricky problem. So that was Tim's case in the. Oh, look at this! We've got a crowd. This is awesome. I was looking just before I started. It was like one person waiting. I'm like, oh, there's going to be quiet, but nope. We've got a whole gang in the house. Hello, Brahim, Eric, Harry, and Lorenzo. All right, so yeah, that was one thing, and then a very similar problem came up in the MEWC Madagascar round 1. They had kind of 2 regular cases and then one set aside as the, this is unreasonably difficult, but give it a swing anyway, bonus case. And that was also about making sets. There were some additional constraints there, and also some additional things. So like there, you were drawing from 2 different decks up to 40 cards. So you could have, maybe a 2 here and a 2 here and whatever. But same basic idea. There were additional constraints there that you had to have a certain, you had to have, I think, at least one run of 4 or at least one set of 4 across, and you had to have a mix of vertical and horizontal runs and other things, but the same basic idea. And then the other case motivating this is one from Harry Gross's dynamic case, which is about like cutting a chocolate bar, cutting a like 256 piece chocolate bar into pieces all of the same shape in such a way that every piece has exactly 1 almond in it. And that is also a problem that this is going to work for. So I've actually recorded my solve of Tim's case, and because I had the weird method that I'm going to use today in mind, I probably went a little, cannonball to swat a fly with it, but I did it that way. So that video will be up shortly, which might make some of the motivation for this make a little bit more sense, but too late. But I'm going to kind of briefly try and take you through the setup there. All right, so I'm trying to think what order to tackle this in. I think the first thing, even though it's not the most exciting part, is going to be something to make the sets. So the setup I'm going to have here is basically I'm going to flatten this this sort of shape, this 52 4x13, into a single column, and then I'm going to generate a column for each possible set. And then I'm going to have a function that will say, for each possible set, is that contained in this starting point? And if it is, subtract it out and give me what's left. And if it's not, just we'll filter that out later. And then, in this case, there's a maximum of 12 cards, so you never have to, take more than 4 steps to take out as much as you possibly can. In the Madagascar one, there were up to 40 cards, but you never had to take more than 4 sets, but you had to take them in a particular way. So yeah, we can basically just iterate that. So let's start with how do you get all the sets? So I'm going to start by just saying to call of my card order and suits. So this is what we're, is this the way? Yeah, that's fine. That's fine. I was debating whether this is the way that I want to read it, but I think it's fine. So what would 3 or 4 or 5 cards in a row look like? Well, at its most basic, if I imagine, let's see, that's 9, 10, 11, 12, 13, and that's by 4. So if this is my box, then 3 in a row would look like this, but you could move it around. So it might be here, or it might be here, or it might be here. And then we'll need to flatten it to line it up with this shape. So my shift is going to come in handy here. So I could say shift of this, and I want a row shift of 5 and a column shift of 2, and I want to wrap, and that gives me this. So now it's down here. And also, because I have the wrap option, I could also shift by, I guess it's 11. We'll get, yeah. So if I shift by 11, then this would be, queen, king, ace. Which again you might have to handle differently. So in Tim's one, I think he said aces were only one of high and low. In the Madagascar one, aces could be either high or low. So you'd have to kind of allow for that. So how am I going to make all of these? Well, the idea is basically with bicall. So we're going to say bicall. And I'm going to start from a sequence of 4 potential column offsets, so 0, 1, 2, and 3. And then I can say lambda call shift will be shift of this by call shift with wrap. And then they look a little funny because of the way they're positioned, but if I kind of box them, it'll be easy to see. I'm upstairs. Maybe 12:30 or 1? Okay, great. See you then. Sorry, where was it? Right. So here we've got it here, here we've got it here, here we've got it here, and here we've got it here. Now in the end, I'm going to flatten it out so that these are all kind of single columns that I can compare to, this setup. But for now, we can do that. And then we could also do the same thing with bicall of sequence, comma. So let's see. I have to do 12, I guess, starting at 0. Lambda row shift. And then we'll just put in row shift here. And then close the lambda, close that. Everyone's upstairs. Exactly. So now, let me see. Yes, so here's my original 4. So then here's my next 4 where everything is shifted down. And then here's my next 4 where everything is shifted down again. And if I zip along to the end, yeah, so I've just got to the stage of wrapping one around. But I can generalize this even a little bit further, which is, so in the Madagascar one, for example, I wanted a pattern of 3 in a row. I also wanted a pattern of 4 in a row, and I wanted various different across patterns. So rather than starting with this whole thing, let's start with just the array that I'm interested in, and then let's expand that to 13 rows and 4 columns, padding with 0. And then, so I guess let's just say let array, I'll call it pattern, I guess. Let pattern be this thing. And then I guess call it total rows can be 13, total calls can be 4. So now this is expand pattern to total rows, total calls. What else do I need to do? This 4 becomes total calls minus columns of pattern plus 1. And likewise, this, that's an interesting one. I guess I'll have to put some argument that tells me whether I'm pushing to wrap around or not. Okay, so for now, I'm just going to have call it max row shift, and we'll make that 12. And then later I'll do some kind of if omitted stuff, max row shift. Okay, so now everything is variableized. So now, for example, if I said pattern was 1, 1, 1, 1, then, right, because the 12 is not good. So fine, make that 11 for now. Again, we'll have to screw around with that later. I don't like that. I want this to be max row shift adjustment, and I'm going to make it +1. How big could the dimensions go in the dynamic arrays, Harry asks. And the answer is like 1,000,000. Yeah, I think the biggest dynamic array that you can have is like 2 to the power of 20, either row limit or column limit. So like you could have one that's 1,000,000 columns. You couldn't output it to the grid because there's only whatever 16,000 columns, but you can have one that's 1,000,000 columns. All right, so then this, I want this max row shift to become total rows, minus rows of pattern +1 plus max row shift edge. I guess I could do the same for column, but right now I'm only thinking of it for cards, so that's fine. Okay, so then let's say that instead my pattern was 4 of a kind. It doesn't like that. Oh dear. Why not? Probably because this is, let's see, total calls is 4, columns of pattern is 4, yeah. So, yeah, sequence of 1 starting at 0, they don't, not sure why that's a problem. I did tell you, Hayden, that it was going to be crazy, and crazy it will be. Yeah, it's going to take a little while to get there, starting from here, especially because I'm trying to lambdify everything as I go, but if it works, it's going to be great. Okay, so hang on. Let's just name all this mad stuff out for a second and just try and see what's going on here, because I don't want it broken yet. 0 to 13. Right, okay, fine. So in this case, I want my max row shift adjustment to be 0, but that's not the problem. Okay, so then my other sequence is here. And that is just 0, but that should be fine. We can shift by 0. So let's take this and give it whatever, 0, 0. Oh, sorry, no. Here, give it 0, 0. That works completely fine. Okay. So then the inner bicall should work. No, what? Name error. Last off is just eyeballing. Yeah, this is the challenge with a question like this. Like, humans are very good at spotting the patterns. There are lots of shortcuts and kind of heuristics that you can take. I will say when we get to Harry's almond one, that is harder to do that way. But one thing at a time. Okay, sorry, where was I? Yeah, there's a name error here. So tot rows, tot calls, row shift, call shift. Oh, sorry, yeah. I'm taking the inner bycall, so row shift is not defined, so just put 0 there. Okay, that works. So what's the problem? If I put 1 there, that works fine. Super confused. Let's go back to having out. Oh, okay. I guess I don't know what happened there, but anyway, it's working now. So here we can get, here's 4 of a kind here, 4 of a kind here, here, all the way along. Okay, so I think that's good. Now, how do I want to lambdify this? Probably want to, I think I want to curry all of these so that I can just have a lambda that takes a pattern. Okay, so let's do this. Let's say lambda of tot rows, tot calls, optional max row. Let's just copy this so I don't make silly typos. And I guess I'll put optional max call shift edge as well, just in case. Okay, and then I want lambda pattern of all that. And then 2 more closing brackets. Okay, so then I want to call, wait, no, yes, I've got this the wrong way around. So I want lambda pattern on the inside. Okay, and then I'm going to take this guy and put it here. And then I want to take all of this stuff out. And put it out here. So we're going to say total rows 13, total columns 4, max row shift adjustment 1, the other one's omitted. So that should return a lambda that takes a pattern, and then I want to give that 1, 1, 1, 1, 1. And then I can get rid of this. And actually, I don't need a let here at all anymore, do I? Because it's just bycall, 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 bycall. Okay, and then, here. I don't need the out anymore. Does that work? No. Oh, crap, what have I done wrong? Which case is this? So this is sort of both, I mean, the general setup right now, but it is for Tim's give me a hand case, and it's for your whatever it was, your rummy case. So hang on, what have I done wrong? Empty array. Shouldn't be any empty arrays here. Right, hang on. Let's go back. Ugh, I hate I'm doing all that. All right, so let's say rows to call. Right, so plus max call shift adjustment. Then I want lambda of all of these things. Then I'm going to get rid of that. Get rid of that. Make this optional. Call shift, and yes, I put that in. Okay. Then I'm calling that on 13, 4, 1. Ugh. What the hell? This is very unsatisfying. Need to go slower. Let's say lambda of dot rows, all this stuff, of 13. Okay, good. Now let's take out dot calls and add comma 4. Okay, that still works. Now let's take this and put it here. Call it 0. Still works. Okay. Let's call shift edge and put that where here? Yes, here. And make that 0. Still works. Okay, good. Now let's make this optional. Yes, and then I can get rid of that. Yes, fine, good. Make this optional and get rid of that. Good. Okay, so I don't know what's going on here, but anyway, fine. So now I want all this to return a lambda of pattern. And we'll just, I'll leave the let there for now. So lambda pattern, this calculation, close the lambda there. So then the outer lambda calls on 13.4, and then the inner lambda calls on this pattern. Come on, come on. Okay, I don't know what I did wrong all the way along, but that'll do. All right, and then I don't need the let out and out anymore. So let's. Okay, cool. So now I want to do that and that. And that gives me all the 3s, including a wraparound for aces being both high and low. Good. Okay, so now I think I want to kill all this and save lambda. Save lambda as. I don't know what I'm going to call it. Call it pattern fill. I don't know. I need to think of a name that will be more intuitive to me later, but for now, that will do. I'm going to say 13.4. Kind of might want that on the inside, but never mind. So I want that of 111. So that's all my 3s, and then I want the same thing for 1111 with the closing bracket. Thank you. And that's all my 4s. And then I also want to consider all the 3 or 4 of a kinds. Is that built-in functionality to save lambda? No, that is OA Robot, which is great, and you should get it because it's free and great. Have I mentioned that it's great? We are joined in the chat by Eric Ohm, who is the creator of OA Robot. In fact, if you look closely, you can see this little smiling robot icon is the same as the one next to his face in the chat, or next to his chat in the chat. Anyway, okay, so for the combinations of 3, I'm gonna take advantage of percom. So 4 choose 3. Wish I could share my solution, but it's too long. I'm looking forward to seeing it. And sorry, for this one, I just want combinations, not permutations. So there are 4 ways that you can choose 3 things from 4, basically corresponding to the 4 things that you can drop. So here there's no 4, no 3, no 2, no 1. But I want these in the kind of 1 pattern, so I'm going to say by row of that. Lambda row minus minus is number x match sequence comma 4 against row. And that gives me that in the format I want. It's vastly more simple. I don't doubt that for a second. Mine will do more when it's finally done. It doesn't do much yet, but okay. So these are all the ways to pick 3, and then I'll just expand that to 4 rows, padding with 1. Oh, I guess I have to, oh, no, sorry, I put in a 2 instead of 4. There we go. Sorry, to 5 rows, padding with 1. So now these are all the patterns in a single row for a 4 of a kind. So, except the trouble is I want to be able to operate by column on this to make it Oh yeah, and hang on, sorry, before I even get into that, I gotta finish this because this is still outputting a bunch of 13 by 4 patterns, but what I wanted to output is a bunch of columns, which I want to fix in the original function because that's kind of what I always wanted to do. So I have to just wrap all this stuff in a to-call. So here, right on the inside, immediately after doing the shift with the wrap, we'll do a to-call. Save lambda. And now we should see this. Yeah. Yes. Yeah, that looks right. And then if I take any of these, let's just grab one somewhere in the middle, and if I wrap it back in 4s, yeah, so that's a run of 3. Okay. So now I want something that will basically take each one of these. So well, let's just do one, and then I'll show you how to generalize it to all of them. Put it down here. So we're gonna pattern fill 13, 4, and this pattern. Yeah, right. So as I wrap rows of this 4. So we've got 1, 2, 3 there, then we go 1, 2, 3 there, and there, and there, and there, and there, and so on. Yep, that looks good. But now I want to apply this to each row here. Can I? No. So if I by row, then it'll stack them vertically, which is not what I want. So I'm going to by call transpose of this thing, lambda call. It's going to be pattern fill, blah, 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 call. That's it, I think. So now let's just see. Each of these should have 13 times 5, so we should have 65 total patterns. I have 200. What? Oh, no. Okay, hang on. Oh, yeah, sorry. I gotta flatten it again. Now I have 65 things. That's good. So let's just take a quick look at them. If I wrap rows this by 4, so that's whatever the first 3 aces, that's the first 3 2s, 3 4s, and then if I bring it across to here, now I'm into this pattern with the whatever 3s, that's 4s, 3s, 2s, 1s, and so on all the way across until I get to 4 kings as my last one. Okay, so now I can, I guess, might as well just mash it all into one frickin' giant formula. I do not recommend this as best practice, but never mind. So I stack that in as well. I need to think a little bit more about ways to make this neater to work with, because obviously even with the pattern fill function, this is still a bit of work to set up, and I think it could be made easier, but whatever, I'll come back to that. All right, so now that I've got that much, yeah, well, let's go get the sort of motivating example, and then we'll work from there. So, yeah, here we are. So, which way around do I want to do this? I guess I will save this. Then I will import lambdas. And then let's get sets. Yes, 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 yes. Okay, so then I'm just going to name this sets. These are all my possible sets. And then I've got a different set of suits here, so I'm just going to go grab the, oh, here they are. So I'm going to say to call my card ord. No, sorry, not card ord. Ugh, stupid. Where there's a lookup table with. Oh yeah, no, it's not complete. Never mind. All right, fine. Let's just do card ord, and then just make this a 10. And then equals this, and 2 row of my suits, which are up here. Okay. So to call of all of this stuff. So that's the cards with some weird symbols for the red ones here, but that's fine. And then the values also relevant. So what ace is 1. Yeah, so numbers are numbers. So do sequence 10. Actually, sorry, 11, 12, 13, so fine. It's just in number order. And then we'll do plus 0 times sequence comma 4 just to make it the right size. So this is card value, and then these are all the sets. So to call of that. Okay. So now for wait, where am I? This is too far down. Level 3. Here it is. Level 3. So I guess let's go to example 3. Let's look up this in here, turning from here. Okay, so then I'm going to do countifs this on this. So this is my starting position, and again, it's easier to visualize for a human. Oops, if you wrap it, and then format comma 0 decimals. Like again, as Danny mentioned, like a human can kind of eyeball this and immediately say, okay, well, there's a set. This one you might not spot quite as immediately because it wraps around, but there's another set, and that's it. And the fewer they are, like in this case, there's never more than 12. Like I find it hard to imagine that there's a formula method that's very competitive with just eyeballing it, but doesn't matter. We're trying to solve a more general case, so that's fine. So now I want to say from this, which of these can I strip out? So first we're going to write the function that'll do it once. So we'll say lambda start and set, or I guess full and subs might be clearer terminology. So we're going to start with full just being one column. Oh, cool. Yeah, thanks, Hayden. I will take a look at that in a little bit if I get a chance. What am I saying? Start full. Okay, so I want to bycall. So first I want to bycall full, because right now this is just one column, but the idea is, if there were, well, here there are 2 different sets I can take out of it, so I want to return what it looks like with each of those sets removed. And then I want to be able to operate on all of the columns in that so that I can iterate it. So first we're going to bycall full, lambda, whatever we'll call it, FL. And then we're going to bycall subs, lambda sub. And then we're going to say if and sub is less than or equal to full, then full minus sub. That's lambda robot. Oh, sorry. Yeah, Eric is answering Danny's question earlier. That makes sense. Otherwise, have I made my? No, I meant to do that, but I haven't done it yet. All right, fine. For now, let's just say otherwise. Q. So that closes that bycall, and then I guess I want to filter. Okay, let. Wait, hang on. Sorry. Which bycall? This bycall. I want to say let. I don't know. STP for step. Be all that madness. Then I want to filter filter, STP, where take STP first row is not equal to QQQQ, and if not found, just give me QQQQ. And I also want to wrap that in a unique by column, because it could be that you have multiple ways of arriving at. Actually, no, at this point there's not. Okay. So that's that. That closes the let. That closes the lambda. That closes the bycall. And then again, once we have this, I think we want to let, I don't know, I'll just call this outer, be all that stuff. And then similarly, I want to filter outer, where take outer first row is not equal to QQQQ. And then this time I do want to take unique by column. Close the let, that closes the lambda, and then for now let's call it on full and sets. And okay, good. That seems to be working. So it gives us, let's just sum these. Oops. Huh? Oh, sorry. Yeah. Just column. Yeah, so here's two different ways that you can take 3 out of it. And if I wrap rows of this by 4, keeps the format that's easier to read, and do the same thing with this by 4. You can see in this case it's taken out. In this case it's taken out this set, and in this case it will have taken out the other one right here, which is exactly what we want. Okay. Now the only other thing is, I think I want an option here that says I might prefer to, I'm going to call it up to. So the idea being that you might want to take out either exactly 1 or up to 1. And if it's up to, then in the cases where you can't take it out, I'm just going to leave the thing untouched so that it does not get filtered out. Although that does mean I do need to put a unique in this step now. So let's put that in, unique of that by column. Then so we're going to say if, sorry, this is up to is optional. So we're going to say if up to, then return FL, otherwise return QQQQ. And then we filter out the QQs and we take the unique, which will get rid of that. That's fine. And this part I think already works. So now I get that, but then if I say up to, then I should, yes. So I've got the two things where I take out 2 different sets, or I've got the original set itself, which will be helpful in some contexts and will just make it slow down in other contexts, but okay. Okay, so this I'm going to call something like pattern remove 1. I don't know, I think I want all of these to start with pattern, but not totally sure. So pat remove 1. Remove of, remove 1. Okay, so now I can say reduce this through sequence 4. Wait. Well, okay, fine. Lambda AV pattern remove 1 of A and sets and up to. See an opening or closing event. Just missed the closing bracket. Okay, so now I've got my, you can have the original set, you can have one removed, the other removed, or you can have both removed, and that's the 6. Okay, so then I want to take this, all of these different patterns, multiply them by the value. Actually, no. So what I'm trying to work out is the value of what I've removed. So what I want is the starting point minus that. So this will tell me here I've removed nothing. These two columns I've removed 3 cards. This column I've removed 6 cards. Then I want to take that and multiply by the value. That'll tell me the value of cards I've removed in each of the situations. And then I want to by call of all that stuff sum. And then I just want to take the max of that. And that is my answer. And if I bring that over here, I set it up like a data table, but I don't really need to do it like a data table. All right, but I do need to bring this bit in. So yeah, let's just cut that, bring it over here for a second. Okay, so point that to there, then take this and put it in here, and also here. Probably should have made it a let, never mind. Okay. And now, hopefully, that'll be right for them. Oops, all right. Hopefully that'll be right for them all, but see, oh, ref error. Oh dear, such a bad start. I didn't lock. Okay, fine. Stupid. I should have named these rather than having to lock everything, but whatever, fine. It is what it is. Cool. You can see some of these spin for a little bit. They're a little calc intense. Okay, here's one where you remove 120. Let's take a look at that. 55. I shouldn't have taken everything out. Never mind. Come back here and grab it. And let's just take the reduce bit. Sorry. All right. Copy that. Put it over here. Just trying to preserve the references if I cut it. Right there. And then I just want the reduce bit. As far as there. What's it spilling into? I didn't think I had anything else down there. Oh, sorry. It's just stuff here. Move it down a little. And we'll bring in the formatting. So, by call of this sum. So you can see you've got the original, you've got 4 different ways to take out 3, lots of different ways to take out 2 sets of 3, 4 different ways to take out 3 sets of 3, and 1 way to take out everything. Now with this one you could say not up to, and it would just give you the 1. But the reason that I did it with the up to is because I'm taking a maximum of 4 steps, but they won't all have 4 that you can take out. So that's the logic there. Okay. So then this one maybe gets saved as its own lambda, but one thing at a time. So what is this? This is, oh, interesting. I accidentally used the Madagascar version with the wraparound, but I guess that didn't make a difference in Tim's question. There aren't that many sets in Tim's question, so that sort of makes sense. Well, except, wait, no, maybe this did wrap around. Oh, sorry, yeah, no, it's, so sorry, for this one I should have put aces at the top instead of at the bottom and not had them wrap around, but anyway. So I guess this set ace 2 3 must just have never come up or never made a difference, but that's fine. Anyway, okay, so now I guess let's just see if we can also apply this to the Madagascar question, and then we'll try Harry's question, which is a slightly different thing. So with both of these, the question is kind of how many sets can you pull out? But it might not be everything. The difference with Harry's question is that you're trying to cover a space with a combination of subsets, which is going to allow things to become more efficient. Now, sorry, I just realized I saved my lambda over here. What do I call it? Pattern remove 1. Yes. So let's bring that back over here to my main file. Keep by call. Yes. Okay. Why is this not opening up? Come on. Come on. Okay. So sort of similar idea here, except that there's some restrictions about how you take things out. So you have so you have to make a 13 from 1 4 and 3 3s, and it has to be either 4 of a kind plus 2 groups of 3 plus 3 in a row, or just realizing this one's actually a little bit different. I don't know if this one is worth the extra setup time as an example over and above this one. So the twist on this one is that there's not just like the ways to get 3 of a kind are not just, you have these 3 or you have these 3 or you have these 3 or you have these 3, because you can have you're dealing from 2 decks, so you could have like 2 1 0 0, or you could have 1 0 2 0 or whatever. So you could exhaustively enumerate all the different possibilities and make an extra giant sets like this. I mean, this one only has 157 columns. Maybe it would be 200 and something, whatever, no big deal. But it's a little tedious to set up that way. So the way with the kind of similar technique, the way that I dealt with this one was basically first I considered, if I go back to somewhere that I have the pattern, yeah, first I considered all the kind of runs like this and took those out, and then I wrapped it into this shape and took the sum across the rows, and then I just considered the pattern as like 3 here or 4 here or 3 here or whatever, and then applied it differently with that. I don't know. I guess people who tune into this stream have a greater than average degree of patience for my shenanigans, so what the heck, I'll do that. Let's do it. Oh, Danny, you're gonna love it. You're gonna love it. Okay, so let's just take one of these. Put that there. I lost the cards. Right, so I need to figure out my set of sets for this one, which is a bit different from Tim version, but let's start from this. So, hang on. First things first, I better import my lambdas. Okay, so then let's go pattern fill, 13 rows, 4 columns, 1 extra row adjustment, and 1 1 1. So these are my, I'll call it runs 3, and then I want to do the same thing. Let me just write it again. Pattern fill, 13 4, 1 extra, and 1 1 1 1. I call that what? Runs 3? Yes, let's call this runs 4. Did I spell it out, or I don't know what I did? Runs 3, I spelled it out. All right, so I'll spell this one out as well. Runs 4. And then the other one is extra simple. Pattern fill. I don't even really need to do pattern fill, but what the heck, I'll do it anyway. Of 13 and 1 of 3. So these are all the ways that I can have 3 of a kind. And I mean, it's even overkill to do this with pattern at all, but whatever, that's fine. So then this is 3 of kind and 4 of kind. Yeah, the thing you'll find interesting with this one, Hayden, is that depending on how you did it, like the idea with this one is you need to find, so there's up to 40 cards, you need to find at what point along the way you get enough. And so like if you go straight to the 40 and look for all the patterns you can find there, you'll have a lot more, because there's a lot more cards there, you'll have a lot more things overlapping with each other and potential conflicts, and the number of possible cases getting bigger. So if you can write it in a way that you start off at whatever 13 cards, because that's the least where you could win, and then test each one and grow as you go, and stop when you need to, because I think it usually stops at around 20 some odd cards, then it'll be a lot more efficient. But anyway, that is what it is. Okay, so then let's see. I want all my cards, which, yeah, I should really have a version of the card ord name that is actually, now that I'm saying it, I should really just do it. So let's come back over here. Let's do card ord. Copy and new. I'm gonna do card ord long. I just put the 1 0 in there. Okay, and then we'll come back over here and import. Did I save before? Yes, I did. Okay, cardboard long and 2 row of suits. Okay, so there's my cards. Then I'll do countifs of my input cards. No, hang on, sorry. So I want to, whatever, let's just start with 25. Or let's see, where 27 is the tipping point. Fine, so let's go 27 for now. And we'll do countifs take of this by this is this. Okay. And I mean, you can see it's still, this is still probably pretty human doable, but you can see it's getting harder now. So like, I don't know, you could do a 3 in a row there, and a 4 in a row there, and a 4 of a kind there, and a 3 there, and I'm guessing that's probably what it is. 26, does something come out of one of those? No. Oh, wait, sorry, because I'm taking first 26 rows. There we go. Now it's not quite so easy to find. All right, so let's see, you could get 4 of a kind there, 3 of a kind there. Oh, right, sorry, it's 26, so 27. There we go. Then another one comes in. I was thinking I couldn't do that. Okay. All right, so anyway, now I want to call this. So then I've got my remove, pattern remove 1 from here. And I think what I want is actually lambda pattern and num. I'm going to pattern remove 1, and then I'm going to choose num, and it's going to be either whatever it was, runs 4, runs 3. Yeah, I'm just doing runs to start, so it's just runs 4 or runs 3. I don't know why I used choose. Well, anyway, doesn't matter. And do I want up to? No, I don't want up to. So that's my lambda, and then I call, wait, sorry. Call this start. Okay, so then I want to call that on here. And 1, we'll come back to it in a second. Okay, so then my different patterns are, I can do runs 4, which is a 1, and then 3, 4, wait, 4 cards? Sorry, that's not, this is 4 in a row of the same symbol. Right, sorry, so yes, that's that one, which is runs 4. Yes. Hang on. Let's just take all of these, bring it over, be able to make more sense of it. Oh, dear. Harry says, starting to get a little stuttering. Not sure if network or your laptop battery. It shouldn't be the battery because I'm plugged in. Oh boy. Plugged in, but apparently struggling. Maybe it is the battery. Yikes. Oh, my laptop's getting old. Well, that sucks. I mean, it's still at 34%. This shouldn't be a problem. All right, I guess we'll dial down performance a little. Anyway. Sorry, where was I? Okay. Okay, so 4 cards in a row of the same symbol is a 1, and then 3 cards in a row with the same symbol is a 2. And then 3, 3. 4 cards in a row with the same symbol is a 1. 2 sets of 3 cards in a row, so that's 2, 2, and then a 3. 2 in a row with the same symbol, so that's 2, 2, and then 4 of a kind, and 3 of a kind, so that's 3, 4. And then 4 cards with the same number, plus 2 groups of 3 cards with the same number, plus 3 in a row. Okay, so that's a 2 for 3 in a row, and then 3, 3, and a 4. Okay. Okay. So then Sorry, what am I doing here? I feel like I've tied myself in knots now. What is this case called? It is called Two Superhero Extension. So the Madagascar round 1 cases, I think, were like from Excel Pro, 2 Superhero, and then 2 Superhero Extension, which is this one. Sorry, where am I going here? As you can see, I still definitely need some practice and some thinking to actually make this work, but where was I? Oh yeah, so, all right, overcomplicating. Let's just pattern remove 1 from start by runs 4. That's name. Oh, sorry, from here. And then, so that's, right now I'm working on this row. Just color that. And then pat remove 1 from that by runs 3. Now I've got a bunch of different options. And then I want by call of that, lambda, lambda call, what am I trying to do? I'm trying to say wrap the rows and then sum it by call, no, by row. So by row, wrap rows, call in 4s, sum. Good. And then I want to remove pattern 1 from that by, so I need 3 in a row twice. 3 of a kind, and then pat remove 1, 3 of a kind. And that seems to be saying there are lots of options, but if I go to 26, there are not options. Good. That's basically what I wanted. So then I just say is number at all of this stuff. So that says there's a way to make this work. And then let's just do the same thing for here. So here I want the same 1, 2, but then I gotta move the by call bit out. No, that's just, so I want to take one of these pattern removes out from the outside and add another one in from the inside. So before I do the by call, pattern remove 1 of this by runs 3. And that is false. And then, so here I want to do 3 of a kind, 3 of a kind, and then group. So actually this is a better one to start from. So runs 3. So we do runs 3, then 3 of a kind, and then 4 of a kind. Okay, so I guess there's 2 different ways you can do this one once you get to 27. And then finally, yeah, so this one is, we're just going to do 1 runs 3. And then I need one more on the outside. So let's see, we're doing 1 runs 3, and a 3 of a kind. So we need another 3 of a kind and a 4 of a kind. Okay. So pat remove 1 of all of that stuff by 3 of a kind. Okay. Yeah, there's got to be a more automated way to do that, but whatever. So then, yeah, I guess I'll just mash all these together into one, or that, or oops, that, or that, closing bracket. Okay, so now, I guess I want to say let strt be this, and do all that stuff. Oops. And actually, let's, yeah, let test the lambda of strt, all this stuff. And then just replace each of these with strt, so that's 1, 2, 3, missed one. Where did I miss one? Come on. Oh, wait, it's further down. Yeah, there it is. Okay. So we let that, and then do test of this. Sorry, missed the closing bracket. Happy days. And then we need to get recursive, so we'll say so rec test will be lambda of recursive call and a number, and it'll be if test of something, then number, otherwise rec of rec and num plus 1. And then I just need to fill this in with whatever that test actually is. You won't let me close it. All right, fine, go away. Just say test of 1. Test of, never mind, I don't care. Just do that. And take this. Yeah, fine. Test of all that stuff. Will that work? Too few arguments for which function? Oh, right. Then I need to make the actual call, which is going to be rec test of rec test starting at 13. Ugh, bother. Okay. Then just name that TMP. And what I was going to do, I was going to say test of all of this stuff with 13. That's false, so why on earth is it? If test, then, yeah, no, we should be recursively calling with the number plus 1, so what? I don't know, I'm screwing this up. Anyway, doesn't matter. Let's just make it simpler. We'll say a sequence of 27, 28 numbers starting from 13. Then we will say, so I'll just go back to let test bit. Actually, why don't I just make this its own bloody lambda, make things easier. Save lambda as test. Then do test of that. And then we'll do if that, then or true, otherwise test of, fill in more there, but give me a sec. Test of all of this. We're now pointing to here. And that way we'll only have to, oh dear, but it's not working. Why not? Probably because things are not locked. Yes, because things are not locked. Okay, so we'll lock that and we'll lock that. There we go, and it turns true at 27. Not as neat as if I got it working recursively, but anyway, you get the idea, and it's been an hour, and I do want to see if I can apply this to almonds. There's also a slightly different challenge with almonds that I'll need to explain as well. So anyway, I'm just going to save that and close it for now. I'll save the Tim one and close it for now. And let's go look at almonds. Okay, so there's a kind of fuller explanation here, but the idea is, without any trickery, Harry, that you want to be able to, a good idea is to add custom cards and wrap around. Yes. Oh, this is the problem with, you looking at my lambdas, me looking at your lambdas, us both looking at bows, and everybody looking at everybody else. I keep coming up with more ideas. My list of lambdas that I need to do since I, committed to spending an hour plus a week working on my lambdas has only gotten longer. What could be friendlier than a question? All right, so let's just read through the question. I won't try to abbreviate it too much. So you buy this giant 16 by 16 block of chocolate. So C is a chocolate square, A is an almond square. And you want to cut up the chocolate along the cell borders, so in other words, along here, in such a way that each resulting block is the exact same shape in terms of cells up to rotation, but not reflection, and each contains one almond. The position of an almond within the shape should be evenly divided between each of the squares in that shape. So e.g. if your block has n squares, then 1 over n of them should be in position A, 1 over n in position B, etc. On your shape. And then answer with the total number of cell borders that you would have to cut in total to divide the chocolate. So it turns out you can answer this question without doing the dissection at all, which, Harry, is a much less fun question, I would say, but never mind. That makes sense. That makes sense. All right, so let's just new rule: the format cells that contain equal to A and format, and I don't know, make them a nice brown color for almonds. So, I mean, the first thing you can quickly do is just count ifs. This is C and A, and the answer is that there are 256 things in total and 64 almonds. So in other words, if you cut them into pieces of equal size and shape, then there has to be 64 pieces, each containing one almond, which means each piece contains 4 squares. Now, there are a few different possible shapes of tetrominoes. So you can have a square, but you can pretty immediately see that you can't do a square here because the only way to fill this corner is with that square, and that square contains no almond, so the square is out. You can have a line, and you can kind of quickly remove the line as a possibility as well. I think this corner is the fastest way to do it. So if you think about what could go here, it can't go that way because that would contain 2 almonds, so it would have to go that way to only contain 1 almond. And then you think about what takes in this one. Again, it can't go that way because that would contain 3 almonds, and it can't go that way because that would contain 2 almonds. So there's no way to do it with the 4. The way I'm going to show you could, in theory, work on each of these as well, but I'm just going to do some upfront stuff. So then you've got the two different reflections of this guy. Sorry, I just did that same thing twice. And then you've got the different rotations of this guy, and then you've got the two different versions of the L. And I guess if I just find and replace x with 1, and then if I import my lambdas, boom. So let's do pattern fill. My total rows is 16, my total columns is 16, no adjustments, and then let's just start with this one, because that's my first pattern. And then, yeah, then if I wrap any of these, wrap rows of that in 16s, you can see that we've got a square there, and we've got, if I zip over here somewhere, we've got a square floating out in the middle of it somewhere, and so on. So now the difference with this pattern compared to before is that now we're looking for a complete cover. In other words, you can think of this as starting off with 256 ones as your starting point, and you have to subtract off these in such a way that you end up with all zeros. And that, algorithmically speaking, is actually going to be a lot easier to do. So the first thing I'm going to do is just say by call of all of this, we're going to say lambda call, and we're going to xmatch. Beg your pardon. That's not the first thing I'm going to do. The first thing I'm going to do is, so these are all the possible squares, but I'm only interested in the squares that contain exactly one almond. So let, whatever I'll call this, all pats be that. Then I guess I'll call it one almond pats. Can be filter all pats, where by call all pats times to call of this guy equals a sum is equal to 1. Which thing have I entered too few? Oh, right. So then give me one almond pats. So now I've gone from having, before I had 225, so in other words, you could start the square in any of the 15 by 15 and then go down and to the right from there. So 15 by 15 is 225. And now I'm down to only 104 patterns. And now what I can do is by call of this, lambda call xmatch 1 against call. So in other words, where is the first square of this? And in this case, I can see, oh, actually you can't see because my screen only does partial. So let's, if I put it there, then I think you can see that the minimum of those is 3, which is telling you, in other words, that there is no square that covers either 1 or 2, which makes sense because the squares that could do that are that, and those don't contain any almonds. And so the fact that the minimum of those is not 1 tells you that this pattern is not possible. Now, after this, it's going to get slightly more complicated because I'm going to have to do the pattern and the rotation of the pattern. Which reminds me that, God, I get so scattered. But anyway, I have been meaning to add a rotation lambda for a while because I know the logic, but it is easier if you can just do it. So, if I have a thing already that does flip. So if I flip this, by default, it'll flip it both horizontally and vertically, or I can tell it, not horizontal, and then it'll flip it only vertically, or I can tell it not vertically, and then it'll flip it only horizontally. So basically, if I join a flip in one direction with a transpose, that is a rotation. In this case, that's a counterclockwise rotation, and I think if I did the other flip, yeah, that would become a clockwise rotation. So I want a lambda array rots as a number of rotations, which I guess I'll make optional. And then I want to choose array. I'm going to say if is omitted rots, then 1 rotation, otherwise say mod rots minus 1 by 4 plus 1, so that I end up with a number between 1 and 4. So let's see. I'll actually call it rots clock. rotations clockwise. So I do that and that. So yeah, this is the pattern that gets me a clockwise rotation. Then both rotations should just be flip. Sorry, this should say array, flip array, and then pattern for a counterclockwise rotation should be this, but with the other direction flipped, and then just array. So that's the end of the choose, that's the end of the lambda, and so we'll call it on this, to rotate it. Ooh, we didn't like that. What? Huh? So we're doing 1, which means we should be doing transpose of flip. It's very strange. Oh, sorry. No. Nope. No. I'm not choosing by array. I'm choosing by that. That's why it's going stupid. There we go. Okay. Ugh, sorry. All right. So that is if the argument is omitted for 1 clockwise rotation, or I put it in, and that's 1 clockwise rotation. 2 rotations, is all the way around. 3 rotations becomes an anti-clockwise. Equally, -1 rotations is an anti-clockwise, and 4 rotations or 0 rotations or 168 rotations is just leaving it the same. Okay, good. So then I'm going to save lambda as, I'll call it rotate. Okay, then I want to bring that back into my main lambda workbook, which is, that's this one. Okay, so now for this one I only need to consider 1 rotation because it's symmetrical in a 180-degree rotation. So we'll say h stack of pattern fill of this and pattern fill of rotate of that. And here we do have a 1. But yeah, anyway, we already checked that we can't do it with that one, so that's fine. We'll move on. So now let's, I don't want to keep repeating the pattern, so let's say this is the pattern now. And then we'll just use pat in all of these. Actually, sorry. Yeah, that's fine. Pat and pat. And again, this one has 180-degree rotational symmetry, so that's fine. And again, here there's no 1, so that pattern is not a possible candidate. And this pattern, there is no 1, so that pattern is not a possible candidate. And then next up is this pattern. But this one I need to rotate all 4 times. So we'll rotate pattern twice, and we'll rotate pattern 3 times. Ooh, we didn't like that. What have I done? All right, let's just hit undo for a second. All right, well, let's just do 1 piece at a time. First that's not a problem, good. And h stack this, so copy, paste, comma, paste. That works, good. And then comma, paste. That works, good. And then I want to rotate pattern twice. That's still fine. And I want to rotate pattern 3 times. And that's still fine. Okay. And so, here we do have a minimum of 1, but we have a max of 239, which doesn't seem like you're getting, hang on, sequence of 16 times 16. Yeah, so 239. I don't know. Anyway, all right, let's just say this is a potential candidate for now. I don't think it is, but let's say that it is. So then, let's try. The thing that we want to change this time is we don't want to just try removing every one of these separately. So because we're going for a cover, let's start with to call of sequence 16 by 16, start in 1 step 0. So that's just 256 ones. So I don't want to remove, just any one of these higgledy-piggledy. What I want to do is to be systematic, to say first I'm going to remove the very first one to appear, and to do that I can only use something whose first thing is in position 1. And equally, if after, let's say I remove these 4 and then I have this left, then I can only use something whose first position is position 5. So basically I'm filtering by these. So instead of having 402 different things, I'm going to have a handful of different things. So let's think about how we can do that. So I'm going to say equals let sets be all of this. And then I'm going to have first be by call sets, lambda call x match 1 against call. Where's my colors here? Close the by call, and then just put first for a second. That'll spill whatever. Say to call, so I can see it. Yes, that seems fine. Okay, so now I want to reduce starting from here, and I want to take 64 steps. And at each step, I want to remove something that has the right first position. So I'm going to say let first from A be x match 1 against A. Then I'll call it filter sets. Can be filter sets where first equals first from A. Then let's just say if not found Q. Then then we'll say if filter sets equals Q, then Q, otherwise pattern remove 1 from A, and we're removing filter sets. But let's not do 64 steps for now. Let's do 1 step. Okay, so there's only one thing that can take out. So sorry, we're looking at this one. Yeah, so there's only one thing that can take out here, because this one can't do it because it gets no almond, so it has to be this one. So there's only one that can take that out. That makes sense. Let's go 2 steps. There's still only one possibility. So having done this, yeah, that makes sense. There's only one thing that can take this out, which is this. Okay, let's go 3 steps. Okay, so now there's a few different ways. So having done this and this, yes, that makes sense. You've got a few different ways you could take this. So you could do it like this, or like this, or like this. And those would all have 1 almond. So that's fine. Let's go 10 steps. Probably going to get too big to fit in here now, so let's move it down into some more space. Oh, no, so that probably breaks along the way at some point. So let's go whatever 4 steps. I'll figure out a fix for when it gets broken in a second. Okay, so maybe it's always broken after that. So what we did this one first, then we did this one, then we did different ones to take that, and then 1 of or 2 of those 3. So then we should be able to take that, no matter what we've done there. I don't know why we can't go 4 steps. Here, no, even there it shouldn't break. Oh, unless, wait, maybe it's not numbering the way I'm thinking of. So let's do to call sequence, no, not DIRS, sequence 16, 16. Yeah, no, it is, it's numbering them along the top. I don't know why that is not working. So in all of these cases, the next thing to come out is 6. 1, 2, 3, 4, 5, 6, which is here. Oh, sorry, wait. Oh, I must have miscounted. So hang on. We do here. We do here. We do here. And something. Oh, yeah, okay, fine. No, you should be able to. Yeah, so this is position 6, so you should be able to take it out with that. So that's what I want is a 6, 7, 8, and then 23. Let's just see. Sequence 256. 6, 7, 8, and then 23. Do I not have something here that is all ones on that? It's more debugging than I really want to be doing. But I do kind of want to get this one out. Yeah, okay, there is a 4 there. So what's the problem? There it is. So why is that one not coming out? Oh, I bet it's because it's something about partials. Okay, so let's do remove pattern 1 from here by sets. Sorry, by filter. This, where this equals 6. Okay, so that is working. So it must be that one of them is not working, and then it's breaking the whole thing. So I just have to make it a little more robust. No, they're all working. Okay, really? Now I'm not happy. Okay, so then let's say remove pattern 1. Sorry, let's just go to that and point this to the whole thing. And that works. So what the... Um, Go to 4 there. It says error in value. Okay. So let's take this inner let. So let A be all of this stuff. Call that out, and let's do first from A. Oh, first from A, you're not happy with what? That's not good. Oh, right, because you have to do it by column. That's what it is. Okay. Yeah, stupid, but fine. That makes sense. All right, so for lambda AV, then we want to bycall A. Lambda call. That first from call. B X match 1 against call. Yes, 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 then call. Then I want to let what do I want to call this? I guess op all calls, be all that stuff. Then I want to filter op all calls where take op all calls row 1 is not equal to Q. Of course I made a mistake. Invalid name error. Why? Up all calls. Be all that stuff. Then we filter up all calls. Take up all calls 1 not equal to Q. That seems fine. Um, oh, sorry, here it is. First from A instead of first from call. I changed the name and didn't update it. Okay, stupid. All right, so now if we go to 4, yes, good, that works. We go to 5, it's broken. Oh no, sorry, it's spilling, but not broken. Okay, if we go to 6, we go to 7, we go to 8. My expectation is that once we get kind of back round to the next row, that'll be where the tension comes back in a little bit again. But anyway, so it's 9, 10. Yeah, so at 10 it seems to be broken. Empty array. Okay. So let's just see if we do X match 1 against that. Count ifs. This is that. Yeah, there are some for, not for all of them. There's nothing that takes in 30, or nothing that starts with 30. But there are some for the others, but they don't fit, which is fine. That kind of makes sense. So then, I guess I want to say, yeah. So here, where I'm saying filter, operate on all calls, take that. Then I want to say if that's not found, Q. Then I can go 10 steps and it'll give me Q. No, it won't. What? Give me calc. Ugh. Why? Somewhere here I'm not allowing for something to go wrong, which is annoying. So here I'm allowing the possibility of Q. Here I'm Q. That's bothering me. Just say if A equals Q, then Q, otherwise do a bunch of stuff. Whoa, okay. So what's going on here? Value not available error. I don't know what the hell that means. So we come back to 9 for a second. Oh, now 9 is broken as well. Oh, shit. Oh, sorry. Yeah, let's make it if at A equals Q. Okay, now 9 is fixed. 10 is still a calc error. Why? 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 Okay. So let's go back to 9 and do the operation again. So we'll keep sets, we'll keep first, rid of the reduce, rid of the lambda. So then we'll bycall on this. Lambda call, one against call, build sets, Q, yes. Move, build sets, fine. Okay. Gives an error, okay, so try operating on less of it. Just one say, that's fine. That's still fine, interesting. So So let's just find which one is breaking it. Okay, so this one, if I operate only on that one, is it still? Yes, it's still breaking it. Okay, so this one, let's X match 1 against that. That's 28. I guess that might be the one that there are none of. Let's see, count ifs. This 28. There are 3 28s. Okay, so what in the F is the problem? Okay, so let call be, sorry, yeah, what's going on? Give me back my keyboard, you stupid thing. There we go. Call me that. First from call is that. Filter sets is that. Yes. okay, right. Yes, this needs an at. Ugh, so stupid. But still, hang on. So, just name this out. So, first from call is 28, fine. Filter sets is fine. So then it must be pattern remove 1. Is calc, but I thought I had pattern remove 1 set to bloody well behave itself. Alright, so let's just output filter sets. Obviously need to fix pattern remove 1. So let's see, that's filter sets, and the column I want is in column Z. So pattern remove 1, full is here, and subs is here. Okay, so my underlying lambda is the problem, as it turns out. Edit lambda. So what's wrong with this? So if that's less than or equal to that, then that minus that. If up to, then lower, otherwise QQQ. So we're getting QQQ. Then filter where it's not QQQ, but if there's nothing, we still return QQQ. Take the unique of that, yes. Then we filter that. Flippin'. There you go. Okay. Well, that was bad. Okay. Lambdas on lambdas. Found a few niche errors in my underlying ones before and it's been a pain. Yeah. It's rough. Okay, so now let's try 10. Okay. All right, so now we just need to get rid of the QQQs. First, I'm going to put an at there, and that'll, oh yeah, that simplifies things a lot. And then I just need to filter out. So I guess let's just replace all instances of Q in here with QQQQ. Really just need to make that a constant somewhere in my thing that I can vary so that Harry can't make QQQQ be an answer in a case and screw me. Okay, so now we're moving again, 14, 16, 20. Getting harder now. Getting a lot of different possibilities. 28. Ooh, it's getting slow now. We're starting to come in again. Whatever, let's just go to 64. No, that's too much. Let's do a couple more. Ooh, now it's getting really slow. Ooh, we're up to 1,024. That's not good. That's not good. I was hoping we would not have that many different possibilities. Harry says, would I do that? The answer is yes, Harry. Yes, you would. May have bitten off more than I can chew here. I thought when it was doing the cover and just looking at kind of relatively efficient paths, it would be okay. All right, well, we're up to 40 and we've got 1,500. It's getting slow, but it's not completely dead yet. As we get toward the end, it should definitely come in. Ooh, that's really creaking now, which makes me worry about my battery. Oh no, it is charging slowly. I can't click in Excel now or else that'll interrupt the calculation. Oof, man. Thought I was going to be back to my, semi-regular 1 hour session, but this is running long. Are you going to make this recursive? Interesting question. I think with a cover, you should only ever have to do a fixed number of steps. You could probably collapse possibilities faster by extending out in a triangle. Yes. Yes, that does make sense. Boy. Oh, wait, is that done? Yeah, it's done. Whoops. How long has that been done? I didn't even notice. 7,000. Oh, jeez. Okay. I mean, it's possible that I need to rely on the other. I don't think this one can even do it. All right, have fun, Hayden. Let's just go 64 and see what happens. Gonna make it really mad now. Hmm. This is not my most exciting viewing, I will not deny. Battery is just about holding on. Come on. You can do it. You can do it. I'm not gonna lie, I was expecting the number of possibilities to really collapse by this stage, because I remember doing some of this by hand when I first tried this problem, and there was like a manageable number of possibilities. But I guess in that case, I was looking for weak points rather than just always going to the next place. But still, by like 40, 50 pieces, you're mostly there. I would have thought it would have either succeeded or failed. Getting close to giving up on this. Getting really close. Trouble is, there is an additional constraint in this, which is the weird thing about, like, you have to have an equal number with the almond in each position, which isn't even totally well defined for this one because of the rotation. There's like 2 inner positions and 2 outer positions. Um, hmm. Hmm. Yeah, I guess the number of possibilities must be exploding in a way that I did not anticipate. I really would have thought by the time it got to the last few, it would just collapse, but that is not materializing. I also was planning to, additional stuff here to say, not just, um, what do you call it? Not just can you cover it, but like which set of the things covers it and that sort of thing. I haven't even, this isn't even doing that. This is just attempting a cover and seeing if it succeeds or fails. I don't know, man. Maybe it's time to give up on this one. All right, it's not done in 1 more minute. I'm calling it. I'm just moving on. All right, I give up. Oh, it's frozen. Of course, it's frozen. Mm-hmm. Maybe it's time to just cut my losses in the stream. stream. um, all right. I think I'm going to probably stop this here. I might play around with this some more and share what I come up with at the next one, or I might try and do more on the next stream on this one. But I think I've made Excel mad now. I'm going to have to go and apologize. So we'll leave it there for today. Thank you everybody for coming along, and especially to everybody who said hi in the chat. And that's all I got for now. See you next time. Boom, boom, boom.